All right. So first of all, another warm welcome to everyone to today's webinar. Today we're gonna talk about individual room control and efficient heating with KNX. My name is Bastian Elsner. I'm the CEO of Elsner Elektronik, and I have the pleasure of being your webinar host today. So let's start with a quite lighthearted question. How many of you guys have turned down the heat control when you left the house this morning? Feel free to give me a quick information in the chat. You can find it on the top right. Also, today's webinar is live, so let's try to make it as interactive as possible. I'm very curious about your questions and the topics that you would like to go in detail further. So feel free to use the chat functionality and ask questions. We are live today and we have time to discuss all your remarks. Today's webinar will take around 20 to 25 minutes. All right. So I would make a quite good guess, I would say. How many of us did turn down the heat control this morning? Probably most of us did not. Another question. What do you think is the comfort temperature subjective? I think everyone knows the situation that you can see in the photo. The heat sensation of people is very, very different. Nevertheless, comfort can also be achieved with even in comparison relatively low room temperatures. The thing is, we need to avoid drafts and we need to avoid harsh temperature differences because this is perceived as unpleasant by most people. Therefore, today we would like to deal with the individual room control because people's sensation of warm varies greatly. All right, let's get into the learning goals for today's webinar. So hopefully after today's webinar, you're going to be able to determine the optimal temperature in different rooms. Also, you will learn how to apply the principle of individual room control in your future or current projects. Next up, you will be able to distinguish and correctly apply the different modes of operation of the different control types. Next up, we're gonna give a quick run through our different room controllers, and you will be able to select the right room controller for your project needs. Let's have a look at the agenda. First up, we're gonna start with the optimal room temperature. Next up, we're gonna discuss the principle of individual room control. After that, we're gonna have a look at different control types. There's the 2-point and continuous controller and the PI control. Afterwards, you will know what all this means. Next up, we're gonna discuss the room temperature controller with the operating mode changeover. This is gonna be quite interesting for your projects. Next up, we're gonna discuss the case if you have two different heaters. For example, you have an underfloor heating and you have a radiator, how you can make them work together. This is considered the two-stage heating. Let's get into it. All right. So the optimal room temperature differs from room to room. The right room temperature has a very strong well-being has a very strong impact on our well-being. I think every one of us knows that already. The optimal room temperature is varying depending on where you are. For example, in the office, in the bedroom, in the living room, or in the gym. Only those who feel comfortable in their environment are correspondingly more productive and vital. Here's a small overview of the most commonly used temperatures in different areas. For example, in the living room study, the temperature is usually in a range between 20 to 22. In other areas, for example, the hallway or even the bedroom, slightly cooler temperatures are recommended. So you see, there's already a problem. We have different rooms where we want different temperatures. So one overall system is not enough. We need to consider individual room control. Let's go over the principles of this. So in the following section, we will look at the principle of the individual room control. we present here a little scheme of a room temperature controller. So the room temperature controller, which can be seen in the box on the left, records the room temperature, and sends a manipulated value to the valve or the actuator. The control valve is approached as a percentage, for example, 40%. Warm water then flows through the radiator or the heating circuit and transfers this heat to the room. The room temperature can then still be influenced by room influences if necessary. The room controller records the temperature again, and thus a control loop is created. Here we have visualized the loop itself. All right, let's have a look how this would look with actual KNX products. So in this example, we show you the schematic representation of an individual room control. The Kala, one of our best-selling room controllers, shown compares the set point and the actual temperature, since it has a temperature sensor integrated in the device itself. This manipulated value is then sent in percentage via the KNX bus to the heating actuator. This opens or closes the valves depending on the controller setting. As a result, the heater will heat more or gives off more heat to the room or less. Therefore, the room temperature is always adjusted to the desired set temperature. The arrows drawn in red show the hot water flow to the heater, and the arrows drawn in blue show the return flow from the heater itself. The two-point controller is one of the simplest temperature controllers. I think most of us know this already. We have it displayed on the top right. This is a very traditional B-metal thermostat that probably many of us know from home or from some other buildings that we have been inside. So the two-point controller is the simplest controller. This switches on when the temperature falls below the set point of the temperature and switches off again when the temperature exceeds the set point of temperature. As already mentioned, I think most of us know those controllers. They have been state of the art for a very long time. In the above example, I have shown you the function of the two-point control within hysteresis. So the green line you can see on the set point is, for example, 25%. So this is the desired temperature that we would like to reach. Then we need to set a minimum value and we need to set a maximum value. This is also called the hysteresis, and this is visualized in the red dashed lines. This is the hysteresis range. In this range, at which the thermostat switches on or off, we assume a hysteresis of plus or minus 1 degree. So this means the controller switches the heating on when the temperature falls below 24 degrees and switches it off again if the temperature exceeds 26 degrees. So that's what meant by a hysteresis of plus minus 1 degree. So if our set point is at 25, the bottom hysteresis, the lower hysteresis should be 24 degrees minus 1 degree from 25, and the top part of the hysteresis should be 26 plus 1 degree from the set point 25. So setting the hysteresis in the two-point controller, you need to take a few things into account here. First of all, the large hysteresis. A few on and off cycles of the heating valve. So this means it's quite gentle. The regulation, therefore, is inaccurate and the control is inaccurate. So the temperature fluctuates around the desired set point at long intervals. A small hysteresis, on the other hand, is speaking about many on and off cycles. Therefore, it's not suitable for heating actuators with relays. The control hits the desired temperature point more precisely. This is clearly an advantage. But also, the valve needs 3 to 5 minutes to open and close, and therefore may not work properly if the hysteresis setting is too small. So there is definitely differences between the large and the small hysteresis, and it really depends on the project itself if you're going for a large or small hysteresis. Let's have a look at the PI control. A PI controller is a so-called continuous controller. For example, the actuating variable can assume any value from 0 to 100. In simple terms, this means that a continuous controller can not only switch on and off, but also sensitively adjust the control variables to the temperature difference to the room. In the above example, we have shown the function of the PI controller and in the above example, we have shown you the function of the PI controller and the continuous controller graphically, the light and blue line. After switching on the controller, the temperature initially oscillates around the set point and then moves closer and closer to the desired set point. Our room controllers that we will show over the course of the webinars all have this PI control integrated. Let's have a look at the advantages and disadvantages of the PI control or the continuous controller. The advantages is clearly that the controller regulates continuously. Also, the desired set temperature is reached very precisely, way more precisely than if you would do it with the hysteresis. The disadvantages. The setting of the control parameters is more complex and must be adapted to the used heating system. When selecting the control according to the type of heating, there's different heating systems. For example, the hot water convector heating, where you have a low flow temperature, and it's good to use the continuous controller or the two-point control. For the floor or wall heating, it's a very slow system, so therefore also the continuous control with a long cycle time is recommended. If you're using a hot water fan heater, the control should be done with a PI control. If a fan is switched together with the hot water circuit, two-point control is needed. What the two-point control exactly is, we will discuss over the course of the webinar. Also, there's the electrical heating, for example, the convector heating. There, clearly, the PI control is recommended. Otherwise, if a fan is also implemented, you will make use of the two-point control. Here you can also see the wording PWM. It stands for Pulsewidth modulation. It's quite a tongue breaker, but let's have a look at what this really is. So, for example, our KNX heating actuators, the KNX K4, receives the control value from the continuous controller and converts it to a pulse-width modulation signal. In the following, we have a look at the pulse-width modulation. For the continuous control, it is necessary that the valve not only opens or closes completely, but that we can also control the valve in various intermediate positions from 0 to 100%. This is realized via the so-called pulse-width modulation control. The valve can move to different valve positions via the ratio of the pulse and the pause time, as you can see in the chart displayed on the slide right now. Just a small example to make it more clear. If the ratio between the pulse and the pause corresponds to 50% each, the valve is opened to 50%, as you can see in the middle graphic. Before we're going to get into the room temperature controller with the operating mode changeover, also called the so-called HVAC objects, I will make a super quick break to give you the options to ask some questions. Once again, reminder, we are live today, so feel free to ask questions and let's make today's webinar as interactive as possible. I'll be back in another second. All right, no question popped up, so I think we can continue. As already announced, now we're going to discuss the HVAC operating modes in the temperature controller. If you have been working with KNX before, most of them should be familiar for you. Most of the temperature controllers in the KNX world have the so-called HVAC options. So HVAC stands for heating, ventilation, air conditioning, and cooling. This HVAC switch can be used, for example, to lower the temperature on the controller display when a room is not in use. It is conceivable to lower the heating depending on a period or calendar, for example, to turn off the heating during school vacations, So here we have quite a huge lever for energy efficiency. All the temperature controllers are often controlled via three 1-bit objects, as shown in the table above. The operating modes can be switched by the means of three 1-bit values. In our products, you can select whether the changeover is to take place via the three 1-bit objects or via the HVAC objects. That gives just a little bit more flexibility. The values executed as X have no influence on the state of the operating mode. As we all know, nowadays energy consumption plays a huge role. So we would like to not only to control the heating, but also to make it smart. For example, we have the ability to turn the heating when people are present in the room on and to lower the temperature when they are absent for the sake of energy efficiency. Another possibility is to lower the heating when the windows are open. Of course, in winter, we don't want it to heat out of the window. We want to keep the warmth inside, so the heating should turn off if the window is opened. So let's look at the scheme that we presented here. On the left controller, we can set the operating mode in HVACs to priority 2, as in this example. If the window contact in the room is closed, the detector remains in switch position 0 and no control of higher priority HVAC 1 is executed. In this setting, the manual setting HVAC 2 operation mode is executed by the controller. Let's make it a little bit more understandable with actual products. So here in this example, our room controller color is shown. The room controller compares the set point and the actual temperature and calculates the control value. The actuating variable is sent to the heating actuator in a percentage. So this opens and closes the actuator or the valve depending on the specification. The color has an additional binary input via which a window contact can be integrated in the control. Via this window contact, the heating system can, for example, lower the temperature to frost protection mode when the window is open. The heating control can also be controlled smartly via a presence detector. Here, for example, the heating could be switched to comfort when presence is present and lowered to standby when absent. This is conceivable, for example, in the use of classrooms or offices. Quite a neat little use case, I would say. I already teasered that there might be cases if you have, for example, an underfloor heating and you have a radiator. This is when we gotta make use of the so-called two-stage heating. It is basically the heating combined with two different heating systems. Usually you use a very slow heating and you use a heater that is quite fast. So you would consider underfloor heating as inert heating because it takes quite some time. So a quick example, the underfloor heating maintains the actual room temperature. If a significantly higher temperature is requested by the user or someone who is entering the wall, then the wall heating can be activated as well, for example, to close the gap to the desired set point. This helps to reach the desired room temperature way more quickly than only using the underfloor heating. How do we do that in KNX? We have to use the two-stage heating. As already announced, I will walk you through our range with some of the room controllers that you can use for exactly what we have been discussing today. Let's start off with the KNX ETR series. So this is our series with frameless room controllers. I will show you most of the devices already, and then we can go over the differences. What I very much love about this series is a very, very sleek design. It's looking very nice on the wall. We can show you in the next slides. We have in all of those room controller where you can see the seven segment digits, we have the temperature control integrated. So we have the integrated temperature measurement. Every device of the ETR series have an integrated temperature sensor, so we also can take temperature readings in different areas of the room, which is very neat for a mixed value calculation. And the first device that you can see is our standard room controller. We have this also in a version with some binary inputs. Next up, you can see a combined version where you also have the possibility to switch or dim lights or to implement some sunshade or window contacts. Next up, we have another room controller also with a temperature controller, but also with a fan coil control. So you can set to low, mid, or high fan coil. Also automatic mode and the entire system off can be realized on the room controller itself. We're quite competitive with the pricing with those products. One reason for that is also that it's a frameless series. So it can be used as standalone and no frames need to be bought with it. You can mount it on an installation box or you can also mount it without. If you have any more questions about this product, feel free to contact us. We will show the contact details by the end of this webinar. Let's have a look how this could look like in a real life setting. So the room controller on the wall itself is quite sleek. So I think it's 2.1 millimeters from the, 2.1 centimeters from the wall itself. It's also quite nice to combine it with the touch panels itself. So what we love to realize is, for example, an overall off with a single gang push button. And as you can see, you can combine it quite nicely with the temperature controller. Usually they are mounted on 1.50 meter height and the push buttons itself on 1.20 meter. Let's head into the next series. I have already showed this color room controller over the course of the webinar. The color KNX comes in different variations. So in this model displayed, there's only a temperature sensor integrated. We have the same device also with a humidity sensor and a CO2 sensor. Some people call this device the Swiss pocket knife of building automation because that's actually everything you need for a full room automation. You have the shading control, you have the temperature control, you have the lighting control, everything in one device. Another neat little feature is the binary inputs that you can either use for making window contacts usable or also a conventional switch for an overall off. Next up, a smaller version from this series is the color KNX 101. It has an integrated temperature sensor and integrated temperature control, as explained before. So this series, the color series itself, is a frame series, so it can be used with all the common 55 on 55 frames. One last model that I would like to show you that can also be used for the temperature control, but works a little bit different since we do not have the 7-segmented digit, is our color KNX Multi-Touch T Light Sunblind. So we have the integrated temperature measurement, also integrated temperature sensor. This accounts for all our room controllers, by the way. They all have an integrated temperature sensor of the color series and the ETR series. Also, you can control with the Color KNX Multi-Touch the sunshade or switch or dim a light. You don't have a 7-segment digits, but you have different LEDs that indicate the heating. So how much more the set point is triggered if one LED is lighting can be configured via the ETS. How does the color series look at the wall? Let's have a quick look. This is our Color Touch AQS TH. So this is the full version with the integrated temperature sensor. Also, nice little information, you do not need an extra power supply. So the normal power supply with the normal bus demand is working fine. All right. Next up, we have the Nuno KNX. This size is 85 by 85 millimeters. It has an illuminated display and we have the integrated temperature controller as well. There's also binary inputs, for example, an NTC or a window contact. NTCs can be also used very neatly to implement them with the underfloor heating. The temperature controller with the HVAC switching is all included. We have also more pages that can be configured, for example, for push buttons. So you can configure this small little room controller also as a 1, 2, 3, and 4-gang push button. All right, I think that's the most important information about our Nuno. And next up, we're gonna have a look at our actuators. So first up, we have the KNX K4. It has the Pulsewidth modulation control integrated and a maximum continuous loads per channel of 8 watt. So the inrush current is maximum 1.1 ampere per channel. The big advantages of such actuators are that if necessary, several valves can be clamped on one channel, taking into account the maximum current consumption. A standard heating valve is less expensive than a KNX control valve. Thus, these actuators can save a huge amount of cost. We do not only have this as a 4-channel heating actuator, but we also have it as an 8-channel actuator. So we were quite fast today. As announced, we're gonna need 25 to 25 minutes. We are at 27 minutes in, and this was the last slide of today's webinar. So I will stay in the webinar room for another couple minutes and waiting for some questions if any arose, so we can take some time to answer those. From my end, thank you very much for attending today's webinar. Elsner Academy is still a new project to us. We're doing this since around about 1 year right now. We're trying to improve our webinar performance from webinar to webinar, but we only can do so if we receive your guys' feedback. So after the webinar, you will receive via the email that you registered to the webinar a feedback form. It will be sent out automatically, and it would help us a ton if you could give us your brutal and honest feedback. Of course, we love some compliments as well, but we can only improve if you tell us what we should be doing better next time. So this product was very much focused, this webinar was very much focused on the methods and the use cases around individual heating control with KNX. We didn't really dive deep into the ETS. If you would like to have that for a future heating control webinar, please let me know in the feedback form or write it in the comments now so we can prepare something. Once again, thank you very much for attending the webinar. I will stay in the room for another couple minutes in case any questions pop up. And besides that, we're at the end. Thank you very much, and hopefully until soon. Bye bye.